Dear students, I am Dr. Ashok Kumar Saini, Associate Professor in Mathematics in the college BLJS College Tosham. Today I will deliver a lecture on real and complex analysis for the students of BA BSc third year semester 6 on the topic Cauchy Riemann equations, CR equations. The necessary condition for fz to be analytic: if a function fz equal to uxy plus iota bxy is differentiable at the point z naught equal to x naught plus iota y naught in a domain D, then the four partial derivatives ux, uy, vx, vy exist at x naught, y naught and satisfy the equations ux equal vy and uy equal minus vx. These are Riemann equations. We will ux curly uy curly x equal to curly vy curly y and curly uy curly y equal to minus curly vy curly x. There is also a note about this. For the sake of convenience, we sometimes use the notations ux, uy, uxx, uyy, uxy to represent partial differential coefficients curly uy curly x curly uy curly y curly 2uy curly x square curly 2uy curly y square curly 2uy curly y curly x respectively. Now proof: since fz is given u xy plus iota vxy is differentiable at a point z naught, therefore f dash z naught equal to limit z approach to z naught fz minus fz naught divided by z minus z naught exists finitely and uniquely as z approach to z naught in any manner. Suppose z approach to z naught in such a manner that z minus z naught is purely real, that is along x-axis. Let us take z naught equal to x naught plus iota y naught and z equal to x plus iota y naught, so that z minus z naught equal to z minus x naught is purely real. Also x approach to x naught when z approach to z naught. Now f dash z naught equal to limit z approach to z naught f z minus f z naught z minus z naught equal limit z approach to z naught f of x plus iota y naught minus f of x naught plus iota y naught divided by x minus x naught is equal to limit x approach to x naught v x comma y naught plus iota v x y naught minus u x naught y naught plus iota v x naught y naught divided by x minus x naught is equal to we are putting the values of fx plus iota y naught in terms of u and v here and separating the brackets is equal to limit u x y naught minus u x naught y naught divided by x minus x naught, separating this plus v x y naught minus v x naught y naught x minus x naught and is equal to limit separating the limits. This limit x approach to x naught u x y naught minus u x naught y naught x minus x naught plus iota limit x approach to x naught v x comma y naught minus v x naught y naught x minus x naught. If as assumed this expression tends to a unique limit as x approach to x naught, then it's real and imaginary parts separately tend to unique limits. If, as assumed, this expression tends to a unique limit as x approaches to x naught, then its real and imaginary parts separately tend to unique limits. But this assertion is equivalent to the statement that differential coefficients ux and vx exist at the point x naught y naught, and then equation second becomes f dash z naught equal ux plus iota vx. This equation number second. If first limit is curly u by curly x, because there is change in only x, therefore this is a partial derivative with respect to x, curly u by curly x. And in the second limit iota limit x approach to x naught, there is change in v with respect to x only. In the first bracket, in the first limit, there is change in x in uxy, therefore curly u by curly x ux. And in the second bracket of limit, there is change in v with respect to x, y remaining constant, therefore I curly vy curly x. Similarly, taking the mode of tending of z approach to z naught in such a manner that z approach to z naught is purely imaginary, and setting according z naught equal to x naught plus iota y naught, z equal to x naught plus iota y, so that z minus z naught equal to iota y minus y naught is purely imaginary. Also y approach to y naught when z approach to z naught. Similarly, taking the mode of tending as z approach to z naught in such a manner that z minus z naught is purely imaginary, and setting accordingly z naught is equal to x naught plus iota y naught, z equal x naught plus iota y, and subtracting these z minus z naught, we are remaining with iota y minus y naught, which is purely imaginary. Also when y approach to y naught, when z approach to z naught, here when z approach to z naught, y approach to y naught. Therefore now f dash z naught is equal to derivative of f dash z naught, limit z approach to z naught fz minus fz naught divided z minus z naught equal to limit y approach to y naught u x naught y plus iota v x naught y minus u x naught y naught plus iota v x naught y naught divided by iota y minus y naught is equal to limit y approach to y naught v x naught y minus v x naught y naught. Arranging this, we are arranging आयटा से आयटा कैंसिल हो गया, ये v आगे आ गया, और ऊपर आयटा हमने मल्टीप्लाई कर दिया, नीचे आयटा आयटा स्क्वायर हो गया, u x नॉट y माइनस u x नॉट y नॉट बटे y माइनस y नॉट। क्या बच गया हमारे पास? पहला फैक्टर v only changes in y, and u factor uxy only change in y, x not remain the same, minus iota है। फोर्थ, Arguing as before, we are led to conclude that partial differential coefficient by and uy exist at x naught y naught, and then equation 4 becomes, this is equation number 4 4 3, this is 4 equation, and it becomes f dash z naught becomes vy, first factor is partial derivative with respect to y, curly y minus iota, second is curly y, as f dash z naught is the unique derivative of fz at z equal to z naught, as comparing 3 and 5 and equating the real and imaginary parts of the expression. On the right hand side we get ux equal to vy and uy equal to minus vx. Equations given by 6 are known as the CR equations, Cauchy-Riemann equations. We can give the alternative proof of these Cauchy-Riemann equations. Let the function w equal to fz. This is the alternative proof. We have given one proof. If there is time, this is alternative proof. You will go through this, and this is, we will do again. We go further because we have proved by one method. Remarks: if we have fz equal to u plus iota b gives curly f y curly x, we partially differentiate it, curly u y curly x plus iota curly v y curly x, curly f बटे curly y equal to curly u y curly y plus iota curly v y curly y. This is, we can differentiate it. From these two results, CR equations in complex form can be put as curly fy curly x is equal to 1 by iota curly f bate curly y. Second, it must be noted that unless the CR Cauchy-Riemann equations are satisfied, fz equal to u plus iota v can't be differentiated at any point, even if the four first order partial derivatives exist करते हैं, लेकिन ये बराबर नहीं है, ये इक्वेशन सेटिस्फाई नहीं होती, तो हम डिफ्रेंशिएट नहीं कर सकते किसी भी पॉइंट पे. फॉर एग्जांपल लेट अस टेक z इक्वल टू x प्लस आइटा y एंड एफ z इक्वल टू रियल पार्ट ऑफ z इक्वल टू z, देन curly uy curly x equal to 1, curly uy curly y equal to 0, curly by curly x equal to 0, because there is no v, only real part is there, real part of z equal to x, imaginary part is not there. So curly uy curly x 1, we partially differentiate with respect u with respect to x, comes out to 1, and there is no y there, and u curly uy curly y 0, and there v part, imaginary part is 0. So curly vy curly x equal to 0, curly vy curly y equal to 0. Thus, although the partial derivative coefficients of u and v with respect to x and y exist everywhere, the CR equations are not satisfied at any point of the complex plane. CR equations are not satisfied although partial derivatives of u and v exist everywhere. Hence, real part of z is not differentiable at any point. Real part of z, this is not differentiable. Fz equal to real part of z x is not differentiable at any point. Second, actually CR equations are useful for proving non-differentiability. They are not on their own sufficient conditions. These are necessary conditions. They are not sufficient conditions for differentiability as shown in the following examples. Find the value of a and v such that the function fz fx equal to x square plus a y square minus 2xy plus iota bx square minus y square plus 2xy is analytic. Also find f dash z. Let fz equal to u plus iota b. Then separating x part, real part uxy x square plus ay square minus 2xy, and imaginary part vxy equal to bx square minus y square plus 2xy. Since fz is an analytic function, therefore u and v satisfy Cauchy-Riemann equations. Curly y curly x equal to curly y curly y curly y curly y equal to minus curly y curly x. Now curly u what a curly x equal to 2x minus 2y equal to curly by curly y. Therefore equation 1 is true. Equation number 1 CR equation is true. Consider equation second, curly y equal to minus curly y curly x. Differentiating it, comparing the coefficient of x and y, we have a equal to minus 1, b equal to 1. Now f dash z curly uy curly x plus iota curly by curly x is equal to 2x minus 2y plus iota 2bx plus 2y. Hence f dash z equal to 2x. Differentiate, we can differentiate it, 2x minus 2y plus iota 2x plus 2y, because CR equations are satisfied. Since fz is an analytic function, therefore u and v satisfy Cauchy-Riemann equations. When Cauchy-Riemann equations are satisfied, we can differentiate the function. Thank you students. You can view this online lecture on our college website www.bljs.com. Thank you.